Yes, sir. I have
All right.
started it right now. Okay. So when you add two negative integers, the resultant will be a negative. So when you add like -3 and -2, the resultant is -5. In the same way, when you multiply two positive integers, the resultant is a positive. So when you multiply 3 and 2, the resultant is +6. In the same way, when you multiply positive and negative integers, the resultant is negative. So when you multiply 3 and -2, the resultant is -6. So you can just substitute those values and you can use that formula sheet. Next, coming to the operations on even and odd integers. What is an odd number? Numbers, when you divide with 2, the remainder will be 1. So when you divide 3 with 2, the remainder will be 1. In this, for example, even if you take number 7, it's an odd number. When you divide number 7 with 2, the remainder will be 1. So odd number, and what is an even number? When you divide an even number with 2, the resultant will be 0. I mean, the remainder will be 0. For example, whenever you have an odd and even numbers in the multiple choice questions or like whatever, you can use number 2 as an even number and number 3 as an odd number. Never use 1 or 0 for substitution methods. Why? Because 1 into any number is always the same. In the same way, when you multiply with 0 with any number, the resultant will be 0. So never substitute 1 and 0 as variables for odd and even integers. So now coming to the formula sheet. When you add two odd numbers, what will be the resultant? It's an even number. So when you add two odd numbers like 1 and 3, the resultant is 4, where 4 is an even number. In the same way, you can substitute few values and you can check the formula sheet. Next, these are few squares and square roots which you need to remember in your mind. Why? Because each and every time you can't use the calculator. So now coming to the basic concepts in arithmetics. So this is the number system what we use. Basically, we have real numbers and all the real numbers are divided into rational numbers and irrational numbers. What are rational numbers? Rational numbers are integers and non-integer fractions. And integers, okay, let me start this way. First, what are natural numbers? Natural numbers, what we use for like counting, like 1, 2, 3, 4, 5, 6, till infinity. Those are called natural numbers. When you add 0 to the natural numbers, it called as whole numbers. And if you take the number line, and when you have the negative numbers with whole numbers, then all the set together are called as whole numbers. Sorry, integers. So integers are from -infinity to -1, 0, 1 to infinity. So integers has both natural number, whole number, and negative numbers. And you all guys know 0 is invented by Mr. Aryabhatta. As I said, what are even and odd integers? If an integer is evenly divisible by 2, then it is called even integer. In the same way, you can just go through the slide later. Now coming to the prime numbers. See, before getting into prime numbers, first you need to know like what is factors. Like factors, you can take it in this way. for a particular product, there'll be like two factors for the particular product. For example, you can take it in like my mom and my dad are the factors for their product. Who is their product? That is me. In the same way, for each and every number, there'll be like few factors. And for those numbers, if there are only two factors, then it is called as prime number. For example, 2. What are the factors of 2? 1 and 2. What are the factors of 3? 1 and 3. And what are the factors of 5? 1 and 5. So prime numbers have only two factors. One is 1 and itself, the number itself. And one and only even prime number is 2. You need to remember that. Apart from that, all the even numbers are composite numbers. And what is composite number? Composite numbers are nothing but which have more than two factors. It might be 3, 4, or 5. How many factors it might be? All those are called as composite numbers. Next, coming to fractions. A fraction is a Latin word which means broken. If an integer is evenly distributed into q parts and that is not a whole number, then the fraction form of a number is written as p by q, where both p and q are integers. You need to remember that. And more precisely, a number that can be expressed in the form of p by q are also called as fractions. To make an example, you can just take it like 2 by 5, 7 by 13, 17 by 9. All these are fractions. They have their prescribed values. Later, I will explain you clearly like what is fraction, what is the depth in it. Just I'm giving you a rough idea like all the number systems and everything. Now, coming to decimals. What are decimals? Fractions normally which can be expressed in other form. Those are called as decimals. When you divide 1 by 4, see 1 by 4 is a fraction. When you divide 1 divided by 4, you will get 0.25, which is nothing but a decimal. And when you divide 1 with 3, you will get a result of 0.33, which is nothing but a fraction, decimal. And in decimals, you will be notifying that, see, just look at this example, 1234.5678. After decimal on the right hand side, it starts with the 10th place, not the ones place. Make sure of that. You guys need to remember that. And I want you guys to learn how to approximate decimals. See, they may ask approximate decimal to the 1000th value, 8th value, 10th value, or something like that. So you guys need to learn how to approximate decimals. That will be your homework. And coming to the different type of decimals. There are three kinds of decimals. One is terminating decimal, recurring decimal, and non-terminating decimal. What is terminating decimal? See, terminating decimal is nothing but when you divide two numbers, you will be getting a finite value. So when you divide 1 with 4, what is the resultant? 0.25. So 0.25 is a finite value. Those are called as terminating decimals. Now coming to the recurring decimals. When you divide 1 with 3, it goes on like 0.33333, so on like that. So they are like reoccurring. So those kind of decimals are called reoccurring decimals. And next, coming to non-recurring decimals. Just take an example of root 2. What is root 2? It is like 1.41421 and it keeps going on. It means there is no finite value. And also you can take an example of pi. When you divide 22 by 7, you will get an answer like very big number. I mean, there is no end for the number. So those kind of decimals are called non-terminating or non-recurring decimals. Next, coming to rational numbers. See, as I told you, the term rational numbers comes from the word ratio, and also you can say like this. Numbers that can be expressed as the ratio of two integers are called rational numbers. What are the examples of rational numbers? You can see the examples over there, like 1 by 2, 2 by 3, 7 by 6. Those are those are like few examples of rational numbers. And what are irrational numbers? Irrational numbers are nothing but non-recurring decimal. Sorry. Hello. Irrational numbers are nothing but non-recurring decimals. As I said, these are a few examples of irrational numbers. Now, coming to the real numbers. The set of all together of rational numbers, irrational numbers, integers, whole numbers, everything are called as real numbers. Those are real numbers. If you see the number line, each and everything is included. See, -3 is an negative integer. Minus root 5, it is an irrational number. -2, again it is an integer. -3 by 2, it is a rational number. -1, it is a negative integer. -0.4, it is a negative decimal number, which is also a rational number. And root 2, it is an irrational number. So set of all the numbers. Either it might be a natural number, either it might be a whole number, either it might be a integer, either it might be a rational number, either it might be an irrational number. Set of all the numbers are called real numbers. See, these are the things they won't ask in the exam, but you need to have an idea like what is an rational number, what is an irrational number. That is the reason I'm just giving you the concepts of these. And these are the few laws you need to remember. See, first one, I want to teach you with an example. Just substitute x is equal to 3 and y is equal to 2. Let's take the first law. When you add x plus y, what is the answer? 3 plus 2 is nothing but 5, which is equal to 2 plus 3, which is also 5. In the same way, when you multiply x into y, which is nothing but 3 into 2 is equal to 6. And if you multiply 2 into 3, which is also same, 6. Then next coming to second law, which is called associative law. When you add, here you can substitute x is equal to 2, y is equal to 3, and z equal to 4. When you add, when you substitute these values in the first expression, x plus y, nothing but 2 plus 3 plus z. Z is nothing but 4, which is equal to 5 plus 4 is nothing but 9. And if you substitute the same values in the next expression, you will get the same answer. The same thing applies to the multiplication also. The next law is called distributive law, which is x into y plus z. can you please substitute the values of 2, 3, 4 in this particular expression? And if you check it, you'll get the same answer. These are the few laws you need to remember in your mind, and wherever it is applicable in the exam, you need to apply them. I'll give you a few examples later, like how to use them and everything. And you all know, when you add 0 to any number, you'll get the same number itself. And also, when you multiply 0 to any number, the product is always 0. And when you multiply 1 with any number, the product is itself. Next, coming to a few fundamental operations like addition, subtraction, multiplication, division. I think you all guys know about it, right? Next, coming to a few number properties. So this is the formula, like Sn is equal to first term plus last term by 2 into n, where n represents the number of terms. For example, if you say like, what is the sum of all the numbers in between 1 to 100, like 1 plus 2 plus 3 plus so on till 100. So what is the first term in it? 1. And what is the second term in it? 100. So 1 plus 100 by 2 into 100, which is nothing but 5050. In the same way, you can use these formulas. First, I want to give you an example. Like, find the sum of all integers in between 20 to 40. So what I am doing, S20 is equal to, I want you to note it down with your pen and paper. S20 is equal to, what is the first term in it after 20? In 21. Yes,
Avinash, sir, I'm sorry to interrupt once again.
Yes,
I think if you can see the question box, and Kiran, do you want to speak? I'm sorry. Kiran?
Yes. There are few questions, Avinash. Whenever you get a moment, you can look at them basically in the same place.
And one more thing, if possible, like, any example you are explaining, maybe better idea if you can show that on the board, maybe, if possible.
Okay, sir.
Yeah.
Go ahead.
Yes, sir.
We're good. Yeah. Thank you. Sorry.
Yeah, it's okay. I think it's better I will show it on the board if possible. Yeah, just give me a second.
So far, I think we have around 4 questions, Avinash.
What are the questions? I can.
If you see the questions here, I mean, I can say, can we see the diagram? Is Siddharth asking? That's one question.
What diagram?
Not sure.
I can't see the question here.
Yeah. If you see under the, if you see the on your GoToWebinar window, there is a questions box.
Yes, sir. Yes, sir. Yes, sir. I can see.
You can maximize it.
Yes, sir. Definitely.
Yeah, and even if you can show the board, I think that looks more interactive, looks like.
Sure, sir.
One of the questions that last year has is, will the given the notes packet, will we be given the notes packet you are looking at?
Just a second. Let me on the webcam.
Okay.
So, can you guys see the board clearly?
Yeah, and one more instruction, like when you see the board, just go and click on the full screen so that you can see the board clearly. This instruction for the students.
When you move your mouse onto the Avinash Kara, the webcam, there is a maximize button that comes in. So you maximize that one, then you can see what he's writing.
So for the example, 21 to 40. If you add the digits in between 21 to 40, like 21 plus 22 plus 23 plus 24 till 40, how can you find it in with the formula? So simple. Sn is equal to first term plus last term by 2 into 100. So here, what is the first term? 21 plus 40 by 2 into 100. 2 ones are 250, sir. And what is 21 plus 40? 61 into 50. So you can do the product and you will get the answer. And I'll do one thing. First, let me give the concepts and everything, and later I'll give you a few examples on the board so that you can understand each and everything. Sir, am I audible?
Yes, Avinash, you are audible.
Okay. See, there are few unique things you need to remember about zero. Like zero is an even integer, and zero is not a positive number or a negative number. It is just neutral. And zero is not a factor of any number, and zero is divisible by every number. These are the few things you need to remember. Why? Because at the time while you're doing problems, you need to use the properties of numbers. So you need to remember a few things about zero and few things about one. And next, coming to properties of one. I think you guys need to go through that once. Like when you multiply or divide by one, you'll get the same. And one is only positive integer with one factor, and one is not a prime number. Please remember that. One is not a prime number and one is not a composite number. Now coming to the concept of PEDMAS rule, which is the most important thing. PEDMAS is nothing but like order of operations. It is just a name which we remember use to remember the order of operations, where P stands for parenthesis. Parenthesis is nothing but brackets, and E stands for exponent. Exponents are nothing but powers and square roots, and D stands for division, and M stands for multiplication, A stands for addition, and S stands for subtraction. So when there is an equation like this, so first you need to go with the one which is in the parenthesis. You need to go with the order. I think this one I will show you on the board. let me do it over here. So what is the question? Three into 5 plus 8 and minus 2 square by 4 plus 3. So now use Pedma's rule. What we should start with? Parenthesis. What are there in the parenthesis? 5 plus 8. First you need to perform this operation. 5 plus 8, 13. So what is the next step? 3 into 13 and exponential. Or else you can make it like this. Till you get habituated. Minus 2 square by 4 plus 3. And after that, what you need to do? Exponential parts. Where is the exponential part over here? It is 2 square. So what is the next step? 3 into 13 minus, what is 2 square? 4 by 4 plus 3. And what is the next step? You need to do the division. Is there any division over here? Yes. So what will be the next step? 3 into 13 minus, what is 4 by 4? 1 plus 3. And later what you need to do? Multiplication. So is there any multiplication over here? Yes. 3 into 13. 39 minus 1 plus 3. So finally you will be ending up with 39 minus 1. 38 plus 3, which is nothing but 41. I hope you guys understood this. I just want you to take a next example. Let me know.
We have a few questions. We have a few questions, Avinash. Do you want to answer that?
Yes, sir.
Yeah. One of the questions was, why are we multiplying 21 divided by 40 divided by 100? Maybe that was from the previous.
This is the previous one. This is the previous one.
Okay. Yeah. So the question is, why are we multiplying the 21 divided by 40 by 2 by 100?
Why?
By 100.
They are asking about this one, this part.
Probably that's the question from Rasmika. Why are we multiplying? I don't know if you can see the question.
Let me check, sir.
Yeah, actually, it may be a good time just to go through. There are like good 7-8 questions.
Yes.
That way, at least they get.
Okay.
Maybe you can come from the top.
Yes.
The most recent question is on the top.
Will we be given notes pocket you are looking at? Yes, definitely. I'll be providing you the notes. What I'm looking at for the PEGMAS. Step for exponent. Is it minus 2 square for positive square positive 4? Okay. See, negative is an here the negative. As I said, what you're doing here, the PEDMAS, this is the order of operations you will be doing. Okay, I'll explain you this concept here. Just give me like 2 minutes. Let me clear the board and I'll get back to you. Can you see the board? Sir, board కనిపిస్తుంది sir?
Yes, Avinash, yes. కనపడుతుంది.
Okay, sir. Let me move the questions to the side. Let me start with each and everything. What is the first question? For the PEDMAS, step for exponent, is it -2 square positive? No. Why? Because let me note it down the question once again. Three into 5 plus 8 minus
2 to the power of 2
2 to the power of 2
divided by 4 minus
no, plus. Yeah. Okay. What is the question? -2 square. She's saying that it should be like +4, right? Is that a question? Let me open the questions part. No. See, if -2, if the exponent is for the whole with the sign of the number, then it should be positive. Here, the exponent is applying only for 2, not for the negative sign. Until and unless if it is covered with the brackets, then only it will be positive. See, -1 square is -1, but -1 whole square is +1. What is -1 whole square? -1 into -1. That is 1. But what is -1 square? Which is nothing but -1 into here minus. Okay. Than -1. I will give you one more example. Let's take -2 itself. -2 whole square is equal to -2 into -2. Here the whole square is the square is applying for both negative sign and the number, which is nothing but -2 into -2 is equal to +4. But -2 square is equal to this one. I can write it as -1 into here the square is applying only for 2, not for the negative sign. I hope you guys are understanding. Here the square is applying only for 2, not for the negative sign. So -1 into 2 into 2, which is nothing but -4. What is 2 into 2? 4. And 4 into -1? -4. So I think the first doubt is clear. Did you understand the first one, the concept? Why it is like -2 square is equal to -4 but not +4? Sir, response. Who is the one? Manasa. Anil sir. Anil sir.
Yeah, Avinash.
Yeah.
I just want to know whether it is clear or not.
Yeah, I think the best thing would be, Avinash, when you answer the question, you can take the student name, just take the first name and say that we are able to answer the question. And the students, if you listen to the question, if it answer, just reply that saying that yes, you got it. That way they would know that thing. Yeah, I know this is the first session. There is a little bit of few hiccups there, but I think we'll set it up in the next one.
Yes.
Yeah, go ahead.
And why are we multiplying 21 plus 4 by 2 by 100? That is the one. Okay. I think the board session is much better than the video session. From the next class, after like a couple of classes, I'll try to make the whole as an interactive session on the board itself. So, what is the question? Perform this. What is the answer? Like, what is the sum of these numbers? 21 plus 22 plus 23 plus so on.
Avinash sir,
Yes.
probably their question may be like, they understood maybe 21 first one and 40 last one divided by something into 100. Why
Yes.
that into 100 is their question?
See, that is a formula actually. That is a formula.
Okay, okay. That's what their question actually.
See, Sn is equal to first term plus last term divided by 2 into 100. What is Sn? Sum of all the numbers. If you say like sum of 1 plus 2 plus till 100, what is the first term in it? 1. What is the last term in it? 100. If you substitute these values in this formula, S100 is equal to 1 plus 100 divided by 2 into 100. 2 ones are 250, sir. What is 1 plus 100? 101 into 50, which becomes 5050. When you add like 1 plus 2 plus 3 plus 4 plus till 100, the sum will be 50-50. It is a shortcut.
Yeah, I think that is the question what they're asking, because into n we said, and in the case of 21 to 40, they may
Oh,
be
sorry.
counting like
Yeah, my fault.
Yeah,
In the
yeah, I
curiosity,
know.
just my
Exactly,
yeah.
into n. So that n is
Yes.
like 21 to 40. That may be
So,
20.
so how many digits are in between them? 20 digits. Here, in place of n, that is my fault. Sorry, as out of
All right, all right. That was their question actually. So that
yes,
they
yes,
got
yes,
confused.
yes. I'm sorry. That is my fault. And do we get these questions afterwards after that? Yes, definitely. Do we reply in questions area? In the formula sheet, it says n not okay. Yes. Shouldn't 21 plus 40 divided by 2 multiplied? Yeah. Yeah. Okay. All these questions are same. Yes, that is my fault. So now next coming to the Pedmas rule itself. Can you guys find the value of y if possible for 5 minutes? I'll give you 5 minutes of time. Can you use this Pedmas rule and find the formula? Can you find the value of y? After that, I'll be explaining how to do that. If you guys cannot do it, I'll give you 5 minutes of time. Can you just do that, please?
Avinash sir, can you put that question on the board too? Because
Yes, sir.
maybe, and for the students, as this is the first class, we are just in the learning curve, and going forward, definitely we'll make more interactive.
Yes, definitely. Y is equal to 5 minus 3, 2, 2. Can you just do this? And there are few tips. Can you see my screen? Use these
Yes.
tips. Use these tips.
Yes, yes, we can.
And you can do that. So, what you are able to see, either my screen or the webcam?
No, we are seeing both.
Oh, you are seeing both? Okay.
Yeah, there will be a side by side, and we are seeing both. Yeah.
Okay.
So I think now we can go ahead and start giving answers because.
Sure, sir. So, according to Pedmar's rule, what we need to check first? Parentheses. But here, there are like many parentheses. 1, 2, and 3. So what we need to do, we need to take the innermost parenthesis and do the operations in that. If there is a multiplication, you need to do the multiplication first. If there is a division, you need to division first. And later, after these two, you need to perform addition and subtraction. Okay, to make you understand, I'll be doing. What is the next step? 5 minus 3. What is the innermost bracket? This is the innermost bracket, right? So what is there in that? 2 plus 6. I'll be performing 2 plus 6 first. So what is 2 plus 6? 8. And later, in the next step, I'll be multiplying. Next, I am doing the multiplication part. 5 minus 3 into 8. What is 3 into 8? 24. And what is the next part? 5 minus 24. What is 5 minus 24? Minus 19. I hope you guys got the answer minus 19. Are you guys able to follow this, or you want me to explain how it's going on? See, if you can see my screen, if there is no operation of addition, subtraction, multiplication or division between a number and a bracket, then it is implied that the operation of multiplication has to be performed first. But here you can see inside bracket there is already addition. So first we are doing the addition and then this bracket goes off. So it becomes multiplication, right? 3 into 8. Then multiplication will be done. 3 into 8 becomes 24 and the 5 remains same like that. After that, after multiplication, what is that? Subtraction or addition. Is there any addition over here? No. But there is a subtraction. So next I am performing the subtraction. 5 minus 24 minus 19. Is there any question? Can we see the diagram? No. 5 minus 24 is minus 19. When you do, see, here it is a positive number, it is plus 5, and here it is minus 24. When the signs are different, you will be subtracting lower value minus, sorry, you will be subtracting lower value from the higher value, but the sign of the higher value will be given to the resultant. So what is the lower value over here? 5. What is the higher value over here? 24. But what is the sign of 5? Plus. What is the sign of 24? Minus. So what is the operation done here? Subtraction. Why? Because signs are different. And in the resultant, the sign will be the sign of the higher value. In the same case, let me give you one example for this. If you do 24, in the same way, I'll do the same. 24 minus 5. What is 24 minus 5? It is plus 19. But if you take the number system, number line, it will be minus 24, minus 23, minus 22, minus 21, minus 20, minus 19, minus 18, and so on till 0. It goes this way. See, minus 24, add like 5 numbers to that. When you add one number, it becomes minus 23. When you add 2, it becomes minus 22. When you add 3, minus 21. When you add 4, it becomes minus 20. When you add 5, it becomes minus 19. The same thing is happening over here. Minus 20, for minus 24, you are adding 5 digits. So for minus 24, when I add 5 digits, it becomes minus 19. I hope you understood how I got minus 19 when I perform this. Yes? Sir, I need to know the response, whether they are able to understand or not. I mean,
I know, but basically, whoever is asking the question, students, whoever is asking the question when sir is explaining, if you followed that, just reply saying that yes, so that at least sir will know that you guys are understanding, or else you can put one more question if you don't understand.
shouldn't 20, yes, okay, y equal to minus 19. So I think there are no more questions on this, right?
Yep.
Okay.
I think there is no questions here. But in case if you have any questions also, we'll come back. You can
Yeah,
continue with the
definitely, sir, definitely. The only thing for the time being, shifting the place, but in future I'll make sure that I'll be sticking at one place itself, and I'll be on the board only.
Mm-hmm.
So next, coming to exponents and powers. See, you can go through the definition what is given. Exponents is nothing. Exponents are nothing but it is an easiest way to represent the multiplication of the number. For example, you can see the example over here, like 7 cube is nothing but 7 to the power of 3 is nothing but 7 into 7 into 7. In the same way, if you take like 2 to the power of 6, it is nothing but you are multiplying 2 for the 2 for 6 times, like 2 into 2 into 2 into 2 into 2 for 6
Um,
times.
Avinash sir,
Sir,
can you see any questions from Mr. Srinath?
uh, questions from screen up. Shouldn't wait. Let me expand it.
Looks like this is regarding absolute values.
I think I didn't go to absolute value yet.
Okay.
It is a next concept actually.
Yeah. Go ahead.
Yeah. Yes. So coming to the concepts of exponents. See, in exponents, you will be having like two things. One is power and the other one is base. In the example, 7 to the power of 3. Here, the exponent is 3, which is nothing but power. And what is the base? 7. Whenever a number is represented to the like a to the power of b, it is like a is multiplied for b times to itself. So here 7 to the power of 3, you're multiplying 7 for 3 times. In the same way, now you will be understanding why it is like why it is not minus 2 square is not 4 and why it is minus 4. Here minus sign is applied. If you see here, minus 3 to the power of 3, it is whole to the power of 3. Here the power is applied for the whole, negative sign and the number. It is not just for the number, it is applied for both. So it is like minus 3 into minus 3 into minus 3. So minus 3 into minus 3 is plus 9 and 9 into minus 3 is minus 27. If it is just like minus 3 cube, I mean if minus is not applied for the whole, then it will be okay. If it is minus 3 to the power of 4, what will be the answer? Minus 27 into minus 3, right? I think the interaction should be more. Yes. Okay, next. There are a few things you need to remember, like for any non-zero real number. You know what are real numbers, right? For any non-zero real numbers, either it might be a negative integer, positive integer, whatever it might be. These are the formulas it will apply. Let's take the first formula. A to the power of 0 is equal to 1. Instead of a, you can substitute a is equal to 3 or a is equal to minus 3. Whatever it might be. Apart from 0, a to the power of 0 is equal to 1, right? So 3 to the power of 0 is 1. And Substitute a is equal to 3 in this second formula. What is a is equal to a to the power of minus 1 is equal to 1 by a. So 3 to the power of minus 1 is nothing but 1 by 3. In the same way, 3 to the power of minus 2 is nothing but 1 by 3 square. What is 1 by 3 square? 1 by 9. And 3 to the power of minus 3 is equal to 1 by 3 cube. What is 1 by 3 cube? 1 by 27. And a into a to the power of minus 1 is equal to 1. A into a inverse. A inverse. A to the power of nothing minus 1 is nothing but a inverse. So 3 into 1 by 3. What happens? 3 cancels and it will become 1. In the same way, there is one more formula called a to the power of m into a to the power of n is equal to a to the power of m plus n. When both the bases are same, when you multiply them, you need to add the powers. This one I will explain you with an example, and I will show you on the board. So can you see my can you see the webcam?
Avinash garu, నేను actually బయటకు వచ్చాను. I'm only on the call.
Oh, okay. So, okay.
I think it's going good. They can see.
Okay. So, where is so a to the power of m into a to the power of n is equal to a to the power of n plus n. This is the formula. Let's substitute a is equal to 5, m is equal to 2, n is equal to 4. Okay. So 5 to the power of 2 into 5 to the power of 4. And what is the RHS? If I substitute these two in this, 5 to the power of 4 plus 2, which is nothing but 5 to the power of 6. Let's prove it. What is 5 square? 5 into 5, right? And what is 5 to the power of 4? 5 into 5 into 5 into 5, 4 times. So how many 5s we have altogether? 1, 2, 3, 4, 5, 6. So 5 to the power of 6. It is not to prove something, but when you need to remember this formula for sure. Like whenever the bases are same and when they are multiplied together, the powers will be added. That is the formula. And what is the next formula you have? And let's do this example so that you'll be having a clear idea. What is the example? A to the power of minus 1, a square a cube, a to the power of minus 2, 1 by minus 3. See, now I'm converting into all to the same basis. Okay, a to the power of minus 1 into a to the power of 2 into a to the power of 3 into a to the power of minus 2, and a to the 1 by a to the power of minus 3 is nothing but a to the power of 3, right? From the formula over here. Where is that? From the formula over here. A to the power of minus 3 is nothing but 1 by a cube. In the same way, 1 by a to the power of minus 3 is nothing but a cube. So here all the bases are same. When all the bases are same, you need to add the powers. So a to the power of minus 1 plus 2 plus 3 minus 2 plus 3. So what is minus 1 plus 2? 1. 1 plus 3, 4. 4 minus 2, 2. 2 plus 3, 5. So the answer is a to the power of 5. So in the same way, let's find the one more problem. I think you guys can take this as a homework, this question. K to the power of A, K to the power of B is equal to K to the power of minus. I think here it's not that clear. I'll be sending you one more copy of this so that you can do that. See, K to the power of A into K to the power of B is equal to K to the power of A. This is what they gave. And they are asking the value of B cube. What we know, when the bases are same, the power has to be added when they are multiplied. So K to the power of A plus B is equal to K to the power of A, right? So what is the next step? When K to the power of A plus B is equal to K to the power of A, which is nothing but A plus B is equal to A, right? So add minus A on both sides. A plus B minus A is equal to A minus A, right? A and A cancels, A and A cancels. So B is nothing but 0. So what is B cube? 0 into 0 into 0, which is nothing but 0. So the value of B cube is equal to 0. So I hope you guys understood what is base, what is power, and how you are using the formula of a to the power of m into a to the power of n is equal to a to the power of m plus n. These are few basic concepts you need to have. Next, coming to the part of squares, square roots and radicals. Yes. See, what is square? Whenever there is a number, like for example, let us take 4. Whenever the power is equal to 2, then it is called square, right? So what is 4 square? Nothing but 4 into 4 is equal to 16. And what is 2 square? 2 into 2 is equal to 4. And what is square root? Square root is nothing but reverse to it. Root 2 square. I mean square root of 2 into 2 is equal to 2. Here in this page, if you see, this is called square root and this is called square, and now coming to the absolute value. So square root of any number is absolute value of square root of x square is equal to absolute value of x. I'll be showing you with example. Wait. So square root of 4 square is equal to absolute value of 4. What is absolute value? Absolute value is nothing but it is the distance between origin and the number. In a number line, if you take -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. If you remove, and this symbol is called modulus. If you remove the modulus, it becomes +4 or -4. If you represent the same thing on the number line, either this point or this point. So the distance between the origin to the number is called, what is the distance? 4 units. 4 units, right? And what is the distance between origin to this point? 4 units. So absolute value is nothing but the distance between the origin to the point. And these are the few examples you need to do it on your own later and find the values, and so that you will be knowing what is the square of an integer, and you will be knowing what is the difference between square of an integer and square of a decimal. And coming to the next, these are few tips as a given, like a to the power of m into a to the power of n is equal to a to the power of m plus n. And here in the second tip, there is a small mistake over here. It is a to the power of m into b to the power of m. It is not n, it is b to the power of m. I repeat, a to the power of m into b to the power of m is equal to ab to the whole to the power of m. Let us take an example. Let's substitute a is equal to 2, b is equal to 3, and m is equal to some 4. So 2 to the power of 4 into b is equal to 3. 3 to the power of 4, which is nothing but 2 into 3 to the power of 4. What is 2 into 3? 6 to the power of 4. If you do the 6 to the power of, when you do 2 to the power of 4 into 3 to the power of 4, you will be getting 6 to the power of 4. When you simplify, it will satisfy both. And what is the next step? Yeah. Square root of a to the power of n is equal to a to the power of n by 2. So let me substitute, instead of m, I'm taking n. So let me substitute the same thing over here. Square root of what is a? 2. What is n? To the power of 4, which is nothing but 2 to the power of 4 by 2. What is 4 by 2? 2 itself. So 2 square. The value is 4. And if you want me to prove it, I can prove it. So if I expand this term, it will be 2 into 2 into 2 into 2. So square root of this is nothing but 2 into 2, right? Which is nothing but 4. And these are the few laws of radicals. Radicals are nothing but square roots. These are the few laws of radicals you need to remember and you need to by heart. Let us take this example. I think you guys need to take this as a homework. It's an easy example. You guys can do it like very quickly. Now coming to the absolute value on a number line. I hope the same example what I taught you just before. Let me clear it up and let me start doing it. So let me okay. When I remove, see the first one, when I remove modulus of that number, when I remove the absolute value of a, it will be either a or minus a or 0. And there are 3 chances. And when it will be a, when it is a positive number. And when it will be minus a, when it is less than 0. I mean, when it is greater than 0, when it is less than 0, and when it is equal to 0. See, to make you much more understand, minus 2 whole square is equal to 4, right? In the same way, 2 whole square is also 4. So when you write square root of 4, which one you should take? Minus 2 or 2? You need to take both. That is the reason we substitute modulus of 2. So when you remove modulus, it might be plus 2 or minus 2. In the same way, modulus of, when you apply modulus, to either a negative number or a positive number, the resultant will be positive only. That's what here. Modulus is nothing but the distance, the absolute value. Okay, to make you understand, I'll give you one more example. Let me do this example. Mod of x minus 3 less than 5. When I remove modulus, it will become minus 5 less than x minus 3 less than 5. Okay? And if I add 3 to all the digits, minus 5 plus 3 less than x minus 3 plus 3 less than 5 plus 3. What it becomes? Minus 2 less than x less than 8. What does that mean? If you take on a number line, minus 3, minus 2, minus 1, 0, 1, so on, till 7, 8, 9. So x lies in between minus 2 and 8. So if you do, when you simplify this, you will be getting the range of x. And blindly remember, when you apply modulus either to a negative number or to a positive number, the resultant will be positive. Mod of minus 9 is equal to 9. Mod of 9 is equal to 9. What, which is nothing but it's an absolute value, right? What is absolute value? Absolute value is nothing but the distance between the origin. Either it is towards the negative side or towards the positive side. There will be no negative distance. Distance is always positive, right? So that is the reason when you apply modulus to it, it becomes positive. These are the few homework things you need to go on and do it on your own. And you need to go through the division algorithm. I'll be explaining you what is division algorithm, and just give me a second. I'll be turning off the camera and I'll be continuing the class. You guys can take break for 10 minutes, please. Sir, can you ask them to take break for 10 minutes, please? Hello.
Yeah, Mike.
Uh, they can take break for 10 minutes, sir.
Okay, all right. Meanwhile, all the students, if you have any questions, you can
Just
go
post them,
ahead and
yes.
keep the questions
Yes.
on the posting. So then once after 10 minutes, class will be revoked. I mean, you know. Yeah, hello?
Yes, sir.
కాల్ చేశారా?
సార్
మేబీ కాల్ చేయండి మళ్ళీ.
ఓకే, అటెండెన్స్ మొత్తం అందరికీ వినిపిస్తుందేమో కదా?
అవును, ఇది మీరు కాల్లో ఉన్నారు, కాన్ఫరెన్స్ లో ఉన్నారు.
ఎస్. Can you able to hear me? Sir, వినిపిస్తుందా? Hello. Okay, sir. Yes. Now coming to division algorithm. In division algorithm, normally in division, you will be having like 4 parts. One is quotient, the other one is divisor, the third one is dividend, and the fourth one is remainder. And when you divide a dividend with divisor, you will be getting the quotient as a resultant. And if there is any something left, that is called remainder. You can remember this formula. This is most important, one of the most important thing in division algorithm. And to find whether a number is divisible by certain numbers or not, there are few rules according to that. Accordingly, just a second, why it was stuck. I think you all have this sheet, right? Please go through that and practice each and every example once on your own. Go through that and do it on your own without saying. It helps you a lot. It helps you a lot in next classes. I'm a bit skipping this division part. Why? Because I think you guys all know how to divide a number. The only thing, just try to practice how to find whether it can be divisible by 1, whether a number can be divisible by 2, how to find a number, whether it will be divisible by 3, and try to do these problems on your own. It helps you a lot. And now the main thing, coming to the fractions. There are few general rules of fractions, like see, if both numerator and denominator are integers and denominator is a non-zero number, then the fraction is called a rational number. Okay, to make you understand, I'll give you a small example. 2 by 5, it is a rational number. See, 2 is a integer and 5 is an integer, and both are non-zero numbers. Mainly, q should never be a 0. Those kind of numbers are called fractions. If both, and you can also keep it in this way, if both numerator p and the denominator q are multiplied by the same non-zero integer, I repeat, if both the numerator p and the denominator q are multiplied by the same non-zero integer, the resultant, which is equivalent of p by q form, it is also called as a fraction. I'm just giving you the definitions to make you understand. See, what is fraction? The numerator part you are dividing into some certain amount of number. When you to remember fractions, blindly remember like this. Whenever you go to a hotel, like sometimes you will be ordering like 2 teas and you'll be dividing among like 5 people, which means you are dividing 2 teas with 5 people. So 2 by 5. Or else you will be, for example,
I'm sorry, sorry to interrupt. Are you explaining on the board or just like you're not sharing the board, right?
sir?
మీరు బోర్డ్ ఏం షేర్ చేయట్లేదు కదా అంటున్నాను.
Oh, board share చేస్తున్నా sir. Okay.
I don't think we are seeing anything.
Okay, I'll be doing it again. Let me erase it and can you see it now?
Yeah.
Let me do it again. See, P by Q form. This is called as numerator and this is called as denominator. What is numerator and what is denominator? I'll give you a small example. Like just sometimes when we go to in India, like we people share, like when we go to a restaurant, for example, I order like three juices, and we are like 5 friends, and we have shared among them. So each person get, I have divided 3 juices among 5 people. 3 by 5. So we are not changing the values. We are equally dividing 3 juices among 5 people. So the numerator is divided equally among the denominator. It is made into equal parts to make it much more easier. See, if you take a pizza slice, how many parts? 1, 2, 3, 4, 5, 6, 7, 8. What are total number of parts? 8. And what is, how many pizzas are there? Only one, right? I'm dividing one pizza into 8 parts. So each part is 1 by 8, right? In the same way, if I divide 2 pizzas, if I consider like 2 pizzas, and if I consider all together, it will become like each part will be 2 by 16. If I consider both pizzas and if I consider all the parts, each part will become 2 by 16, which is nothing but 1 by 8 itself. See, the what I want to say is the value never changes, but the way of notation changes. The only reason because it depends on how, what you're considering it. And there are few types of fractions. Let me get it to you. And there are like few types of fractions. One is proper fraction. What is proper fraction? Proper fraction is nothing but which is in the form of P by Q, and it is not a complex one. Not a complex one. I think it is better I'll share you with each and everything with the slide. Why? Because I have made it according to the slide wise than on the board. Just give me a couple of minutes. Yes. So you can take like types of fractions. One is simple fraction. What is simple fraction? A fraction in which both numerator and denominator are positive integers and they have like no common factors. For example, 3 by 5. See, both 3 and 5 are like integers, but they don't have common factors. Apart from 1. Apart from 1. And also you can take it 3 by 2. If it is 3 by 2, what are the factors of 3, 1 and 3? And what are the factors of 2, 1 and 2? So what are the common factors apart from 1? There is nothing. Those kind of fractions are called simple fractions, just like simple fractions. And like fractions. The second one is like fractions. Like fractions are nothing but if both the denominators are same. I repeat, if both the denominators are same, then those type of fractions are called like fractions. For example, 3 by 5 and 2 by 5. What is the denominator in 3 by 5? 5. What is the denominator in 2 by 5? 5. So both the denominators are same. So those kind of fractions are called like fractions. And what is the other one? Unlike fractions. Unlike fractions are nothing but if the denominators are not same, I mean if they are not equal, those kind of fractions are called unlike fractions. For example, 2 by 7 and 2 by 3. In these, 7 is the denominator for the first term and 3 is the denominator for the second term. Even though numerators are same, but the denominators are different. So those kind of fractions are called unlike fractions. And there is one more called mixed fractions. Mixed fractions are nothing but this one. I'll show you on the board. See, 2 3 by 4. It is a mixed fraction. Here 2 3 by 4 means it is 2 plus 3 by 4. It is not 2 into 3 by 4. Whenever the fraction is like this, it means that it is 2 plus 3 by 4. It is not 2 into 3 by 4. And how you can convert 2 3 by 4 into a normal fraction form? Like it's a mixed fraction, right? How you can convert it? So simple. You need to multiply the denominator with the term on the left side, and then the product will be added to this number by whole. I'll show you. 2 3 by 4. 4 into 2, which is nothing but 8, plus 3 by 4 is equal to 11 by 4. So simple. Here they're representing 2 plus 3 by 4, right? Actually what they are doing, they are adding two fractions. How you can add two fractions? First, what you need to check, the denominator should be same. If the denominators are not same, what you will be doing? You will be finding the LCM. That I will explain you in the next class. But these are the things happening. To convert the complex fraction into a normal fraction, so simple. We need to multiply the denominator with the given the number on the left side, and the product will be added to the numerator part, and the denominator remains same. So, for example, if you take 3 4 by 5, how you will convert this complex fraction into normal fraction? I will be multiplying 5 with 3, which is nothing but 15, plus the product will be added to the numerator 4, and the denominator remains same. So 15 plus 4 is nothing but 19. 19 divided by 5. So 4 by 5 is equal to 19 by 5. If you do in the calculator, you need to do 3 plus 4 by 5. You will be getting the same answer when you do it 19 by 5. So this is how you will be converting complex fraction into the normal fraction. Next. Next, we can go through some examples over here. See, if you see in the example 1, it is 3 by 5 in the numerator part, and in the denominator part, it is 2. This one I can explain again on the board. First point, what you need to remember is any number which is if they want to represent in the fraction way, so simple. If a is the number, a by 1, both the values are same. For example, 3 also can be represented as 3 by 1. You can take by 1 as normal. So what is the first example? 3 3 by 5 by 2. Okay. And there is one more rule, like a by b divided by c by d is equal to a by b into d by c. This is one formula you need to remember. I think you guys can see it, right? This is one formula you need to remember. So let me give an example further. 3 by 4 divided by some 2 by 5. What happens when I take this denominator to the numerator part? When I simplify it, it becomes 3 by 4, and the denominator part, when it goes to the numerator, it gets reversed. I mean, it gets reciprocal. 3 by 4 into 5 by 2. And what will be the next step? 3 into 5 is 15, and 4 into 2 is 8. So I think you guys understood this, how I'm doing. See, whenever there is a form like a by b by c by d, when I want to simplify this, the fraction which is in the denominator, it goes to the it goes and multiplied by the numerator, and in the reciprocal way, nothing but a by b into d by c. So let me show you the first example. What is the first example? 3 by 5 by 2. First example is 3 by 5 by 2. See, here 2 is just a number. But when you want to simplify this, you need to convert it into a fraction form. When there is nothing, you can keep by 1. So what is the reciprocal of 2 by 1? 1 by 2, right? So what is the next step? 3 by 5, which is numerator, into reciprocal of denominator. What is reciprocal of denominator? 1 by 2. So 3 into 1 is 3 and 5 into 2 is 10. So 3 by 5 by 2 is equal to 3 by 10. And what is the next example? 2 by 3 by 7. 2 by 3 by 7. When I want to simplify this, I think you guys can see this. When I want to simplify this, first, what is there in the numerator? 2. If I want to convert this 2 into a fraction form, I can just take 1 as a denominator for it. So 2 by 1 into, and what is the reciprocal in the what is in denominator? 3 by 7. And what is the reciprocal of it? 7 by 3. It is multiplied with 7 by 3. So 2 into 7 is 14. 1 into 3 is 3. So it is 14 by 3. 2 by 3 by 7 is nothing but 14 by 3. I hope you guys understood like how I am getting 14 by 3 and how I am converting it. Is there any questions? And okay, let's go to the next topic. How to compare fractions with denominator. This one again I'll show you on the board itself. When you want to compare two fractions, what is comparing? Like to find which is larger value and which is smaller value. And when you compare two fractions, a by b, comma c by d. When you compare these two fractions, first you need to check whether these two denominators are same or not. I mean equal or not. Whenever you are comparing two fractions, you need both the denominators should be equal. If they are not, you need to make them equal by finding the LCM of both. LCM. So let's do with an example. 1 by 3, comma 1 by 9. If I want to compare these two fractions, how I can say whether which one is bigger? I can't say. Why? Because right now both the denominators are different. First, I need to make the denominators equal so that I can compare it. So to make the denominators equal, first I need to find the LCM. What is the LCM of 3 and 9? 3, 1, 3. So LCM is 9. After finding the LCM, get the denominator in such a way that it is equal to the LCM. Convert the denominator into such a way that which is equal to the LCM. So simple. To get 9 in the denominator, how much you need to multiply with? Or else you can keep it in this way. You need to divide the LCM with the denominator. So 9 divided by 3 is 3. So this denominator should be multiplied with 3. And in the same way, the same quotient should be multiplied to the numerator. 1 into 3. See, here we are not changing the value. We are just manipulating the numbers. The value never changes. We are just manipulating the numbers. So it becomes 3 by 9. The first term becomes 3 by 9. And what is the second term? 1 by 9. When I divide 9 with 9, it is 1. So the second term becomes 9 into 1, and the same number should be multiplied to the numerator, 1 into 1. So 1 by 9. Now this is the first term and this is the second term. So now both the denominators are same. Now you can check which has a greater numerator, that is the greater value. So here 3 by 9 is greater. 3 is greater than 1, right? So 3 by 9 is greater than 1 by 9. What is 3 by 9? The first term. So 1 by 3 is greater than 1 by 9. In the same way, for to add two fractions, for example, 3 by 5, comma 4 by 5. I can add or subtract two fractions when both the denominators are equal. Here, while you're, if they ask to perform 3 by 5 plus 4 by 5, first you need to check whether the denominators are equal or not. If they are equal, then the resultant denominator will be the same of the question. And you will be adding the numerator part. So 3 plus 4 by 5, which is nothing but 7 by 5. It is not like 3 plus 4 by 5 plus 5. It is like 3 plus 4 by 5, which is nothing but 7 by 5. And let us take if denominators are not equal. For the same example, 3 by 5, comma 4 by 10. Here, both the denominators are different. When denominators are different, what you need to do? First, you need to find the LCM of the denominators. What is LCM of 5 and 10? 5 ones are 2s are 5 2s are 10. So 10 is the LCM. And now let us take the first term. The denominator should be LCM should be divided by the denominator term of the first term. So when I divide 10 with 5, I will be getting 2. So I need to multiply the denominator with 2. 5 into 2 is equal to 10. And the same should be multiplied to the numerator. 3 into 2. Why? Because 2 and 2 cancels. So 3 by 5 is nothing. Wait, what is the next step? 6 by 10. See, 6 by 10 is nothing but 3 by 5 only. 2 by 2 is 1. Here you are just manipulating the numbers. you're not changing the value. Here the value never changes. So 3 by 5 is equal to 6 by 10 and 4. So both the denominators are same. Anyhow, you need not to multiply again. So 4 by 10 and 6 by 10. Among these two, which is bigger? Which is greater? 6 by 10 is greater. So 6 by 10 is the first term. So 3 by 5 is greater than 4 by 10. Right? And if you want to add these two, it becomes, what is the first term? 6 by 10 plus 4 by 10, which is nothing but 10 by 10 is equal to, again, if you cancel it, 1. And how to subtract two fractions? So simple. In the place of addition, just do the subtraction. Take few examples on your own and perform the subtraction. You will be understanding for sure. I think Mr. Anil sir, for today, I think it's good enough for today. Why? Because
Okay,
they will be
no,
get confusing. More,
sure,
going like more and more.
no problem. Can you take the question if you have any?
Yes. Hmm. I think that I don't see any questions here.
Okay. All right. So I think for the next class we'll be, overcoming whatever today we are facing. We'll overcome that and we'll come back with a little bit more advanced way of presentation. And we'll take the feedback from the parents too. So kids, you talk to your parents and see how it is going and what exactly you guys need, so that we'll talk to your parents and we'll try to implement those. And Avinash Garu, yeah, thank you very much for the class, and we'll meet once again on Thursday.
Sure, sir. Thank you.
All right. And Avinash Garu, stop the recording and send me the recording to me.
Okay.